Permutation. In previous session of permutation, we have discussed only the first type. What is that first type? It is of permutating. Permutating means it's an arrangement. Okay, arrangement of n dissimilar things taken or at a time. That's what this first type deals about. N dissimilar things taken or at a time. Okay. So how this permutation, the number of permutation is given is NPR, meaning n factorial by n minus r factorial. Okay. So the first question what we are about to solve today, this page number 58, see the first question. From that one we will solve. Consider, from the word consider, find the number of 5-letter words can be framed using the word consider. How many of them begin with C is first subdivision, and how many of them end with R is second subdivision, and how many of them begin with C and end with R is the third subdivision. Totally 3 questions asked. Okay, we have given a word consider, in this how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 letters. We are framing a 5-letter word, right? Forming 5 letters. So for that, how many letters we need from this? So n dissimilar things, all of them are not similar, right? Okay, from this n dissimilar things, which means 8 dissimilar things, we are taking r things at a time. R is 5, n is 8. Okay, so the total number of permutation is, yes, total number of permutation. It is not asked in the question. Just to explain this I am telling. Okay, this is 8p5. This also can be calculated. Now we come back to this question. First subdivision. How many of them begin with C? See, 1, 2, 3, 4. These 5 boxes I made. First letter is C, that I fixed. Remaining how many letters we need? 4. Okay, how many ways this C can be selected? There is only one C. So only one way it can be selected. Into, and these 4 letters we need, this 4 letter can be chosen from any of the remaining 7. 7p4. Actually it is 7 into 6 into 5 into 4. That is 7p4. Okay. Clear? How to calculate 7p4? 7 factorial by 7 minus 4 factorial, that is 7 factorial by 3 factorial. Cancel. So 7 into 6 into 5 into 4. You get one big number. Okay. Also, that gives the definition of one important principle, that is fundamental principle or counting principle. What principle? Or counting principle. Okay, what does the fundamental or counting principle states? See, if an operation can be performed in m ways and the second operation can be performed in n ways, then corresponding to each performance of the first operation, the two operations in succession can be performed in mn ways. See, we are doing one operation, we are not doctors, we are about to become doctors. In this operation, certain things, one operation can be done in m ways, that m is this one, and the other operation can be performed in n ways. Okay, understood or not? One operation can be performed in m ways and the other operation can be performed in n ways. One in succession to the other can be performed in mn ways. That is why we are multiplying these two. Now we will come back to this second subdivision. Second subdivision means the second question is what? How many of them end with R? Don't say one, man. 1, 2, 3, 4. Yes, see, last digit is fixed R. In succession, okay, this is one operation separately, this is one operation separately. Okay, this operation we can do in succession. After doing this, we can do that. Okay, but in this case, after doing this, we are doing this. How many ways this R can be selected? One ways. So 1. Then remaining 7p4. So this can be done in m ways, this can be done in n ways. Both can be done in succession, one after another. Can be done in how many ways? 7p4 into 1 ways. Okay, understood the counting principle? Okay, then see the third subdivision. Begin with the C and end with R. You understood this procedure, right? How it works? That is what the counting principle says. Okay. So here two box fixed, man. 1, 2, 3, 4. Begin with the C, end with R. This can be chosen in one way because these two should not be interchanged. Both are fixed. This can be chosen in one way, this can be chosen in one way. Then remaining how many letters we need? 7p3. 7p5. Man, these two already fixed. 7p3. That's all. Noted these answers down. Note this down. Just the answers. The answers alone in book. Mark it. Hey, just a minute, wait. See, here C has been chosen, here R has been chosen. Remaining 7 letters will be there. 6 letters. You said 7p3. Okay. 6p3 is the answer. Okay. One, 2, 5, 6, 7. We are framing a 4-digit number. 1, 2, 3. 4-digit number. Okay. How many of them divisible by 2? First, totally how many 4-digit number can be formed? How many numbers given? 5. From this, how many we are taking and arranging? So total, yes, 5p4, perfect, correct. Now the first subdivision, it should be divisible by 2. The same 4-digit number. When the number will be divisible by 4? If that is an even number. So the last box has how many choice? Either 2 or 6 can be arranged. So this last box can be chosen in how many ways? 2 factorial ways. That means 2 ways. Okay. Then remaining how many digits we need? 3. That 3 has to be chosen from, see, either 2 or 6. Any one number chosen already. So the total number will reduce to what? 1, 2, 3, 4, 5 numbers given. We already allotted one number. We don't know which number it is. Okay. Consider it is 6. Remaining 4 numbers. From 4 numbers, how many numbers you should take? So 4p3. The required number of ways is 4p3 into 2 factorial. That's all. Now next subdivision, that should be divisible by 3. Sum of digits. That should be divisible by 3 means sum of digits should be divisible by 3. First 3 numbers we can choose as per our wish. Okay. These 3 boxes can be chosen as per our wish. After that, if the last box what number we are putting, that number is divisible by 3 only, the whole number will be divisible by 3. Okay, that is the concept. These 3 numbers, no, first this last box has how many chance? Only 6 is divisible by 3. Only 6 is divisible by 3. So 6 means how many possible ways? One way. So this number is taken. Then 1, 2, 3, 4. 4p3. What is 4p3? From this 4 number we can choose any 3. Okay. One, 2, 5, 7. How come 1, 2, 5, 7 will come? What is final answer? 96. Okay. But as per this concept, this can be only filled by 4 factorial. Totally 24 ways. Okay. We'll check which one is right. This one or that one. You send me that also, I'll give you a clarity. Yes. Then this third subdivision. Third subdivision, it is divisible by 4. What? None of the above. Wait, man. What is the divisibility rule for to divisible by 4? The last 2 digits should be divisible by 4, so that the whole number is divisible by 4. Okay. Okay. Last 2 digits means 12 is divisible by 4. 12. Then 16 is divisible by 4. 24 possible? No. 52? Think one. 52 possible. 56 possible. Then 36 are no 3 is there. 72. 72. Totally how many possibilities? 6. So this 2 box can be filled in 6 ways. This 2 box can be filled in how many ways? 6 ways. Okay. Into The remaining 2 boxes can be filled in 4p2. See, 2 numbers left already. 2 numbers we chosen. Remaining how many numbers? 3p2. Okay. So 3p2 into 6. Okay. Simply 3 factorial into 6. Next, divisible by 5. Are you writing this? Next, divisible by 5 means last digit is fixed. Last digit is fixed. 5. It should end with 5. So only one possibility. One number chosen from what is given. 1, 2, 5. Wait man. Last number 5 fixed 1. Whatever number we fill here, that is divisible by 5. So 5 already taken. Remaining how many numbers are there? 4. From that 4, how many we need? So 4p3. That's all. 4 factorial. 4p3 is 4 factorial only. Okay. Then fifth subdivision. The number should be divisible by 25. A number should be divisible by 25. It should end with 25. Then only we can say it is divisible by 25. So 2 and 5. Only one chance. Then these 2 numbers has to be filled in 1, 2, 3. 75 25 or 75. Okay. And then 65? No, they will not come. Only these 2 will come. So this box can be filled in 2 ways. After choosing these 2 numbers, remaining how many numbers? 3 numbers. From the 3 numbers, how many we need? 3p2. Okay. So 3p2 into 2. Okay. 3p2 is simply 3 factorial into 2. 3 factorial is 6. 6 2s are 12. Okay. Shall I erase this? Next. See the dictionary order question, you just keep it, I will explain at last. Next, the first question in the next set. Question number 1. NPR is equal to n into n minus 1 p r minus 1. Just apply the formula man, NPR formula. N factorial by n minus r factorial. Since we have n here, that n can be taken out and this can be written as n minus 1 factorial divided by n minus r factorial. Are you listening here? So n into n minus 1 factorial. In the denominator also, you should not take any other things out. Denominator also, this whole thing minus this one should come. For that I am making one adjustment. N minus 1 plus 1 minus r whole factorial. Is it possible to add or subtract 1 in between anything? Okay. Now time to group these things. N minus 1 factorial divided by n minus 1. See, these 2 I group, and from these 2 we can take minus out. Then it will become r minus 1 whole factorial. As per the definition, if you apply, means n factorial by n minus r factorial. In place of n minus 1 is there. In place of r minus 1 is there. So we can write it like n into n minus 1 p r minus 1. That's all. Okay. Any doubts in this? Formula. After that, this I expanded like n into n minus 1 factor. Okay. So next question number 2. What is there in question number 2? If np3 is equal to 1320, 1320, find n. What is formula for np3? It is n factorial by n minus 3 factorial 1320. Also this numerator can be written as n into n minus 1 into n minus 2 into n minus 3 factorial divided by n minus 3 factorial, that equals 1320, and these two cancel. We have n into n minus 1 into n minus 2 is equal to 1320. Now if we multiply all these three together, we will get n cube, n square, n, like one cubic equation we will get. Solving cubic equation and all, it's a big deal. That too in the middle of the objective examination that we are writing, the time constraint is very important. That is why we can't solve this and go for this option, cubic equation. We wish to solve means solve if there is no other go, but time constraint will not allow. For this also we are the time constraint is very less. That is why. So how we can find this means, we will try to express this as product of three numbers. The two consecutive numbers, whether possible or not, we will check once. Take the prime factorization of 1320. If you take 2 means what you will get? 660. Again 2, 330. Again 2, 165 or 75? 165, sorry. And then 2 possible, 3 possible, 3 possible. Then 5 3s are 15, and here carry over 1, 5 3s are 15. Again 5, 11, 11. As we are having 11 here, the number we are looking for will include 11 also. Okay, because if you multiply means big numbers will come. This is simply 1320. So you just think either it could be 10, 11, 12, or else 9, 10, 11, or else 11, 12, 13. Among this any one number. I fixed this as 11. 10 is possible in this product. See, 5 is there, 2 is there. If you combine that 2, what you will get? 10 is possible. Then if you combine the remaining things, multiply. 120, man. Only 12. This gives you 12. So this 1200 we can write it as 12 into 11 into 10. Okay. This pair 12 into 11 into 10. That is n into n minus 1 into n minus 2. Just compare this. A number 1 less than the number, 2 less than the number. Multiply it together. What is that number? N then. Then n is what? Not by, compare, man. 12. That's all. Not 12 factorial, just 12. Okay. Shall I erase this? Okay. Next, the second subdivision of the same question. NP7 9 So np7 by np5 which is equal to 42. What is np7 formula? N factorial by n minus 7 factorial whole divided by n factorial by n minus 5 whole factorial, that equals 42. Easily n minus 1 n factorial can be cancelled. Then remaining we have is n minus 5 factorial divided by n minus 7 factorial equals 42. Which one is bigger, n minus 5 or n minus 7? N minus 5 is bigger. So we can write, have you noted this down? So we can write n minus 5 into, what is next less than 1 of this? N minus 6 into n minus 7 factorial divided by n minus 7 factorial, that equals 42. Any confusions in this, how I wrote this? See, what is given, n into n minus 1 we should write. So n is n minus 5, n minus 1 means n minus 5 minus 1, n minus 5 minus 2. So these two can be simplified. Then remaining n minus 5, n minus 6 is equal to 42. This also will give you quadratic equation. If you are good enough to solve the quadratic equation, yes, okay, you can proceed with the quadratic equation, but time constraint. Then the idea, not LCM, prime factor this. Since it is n minus 5, n minus 6, that should be two consecutive numbers. 42 is 6 7s are 42, right? No, 7 6 are 42. See, big number after that small number, in that order you have to write. Okay. Both are same, man, but as per this order, see, two consecutive numbers. This one is big, this one is small. Okay. So when we equate these two by trial and error, this n minus 5 is equal to 7, then n is equal to 12. Or else if we equate these two also, n minus 6 is equal to 6, then n is equal to 12. But if you wrongly equate, you will get 13 as the answer. That is why I said it is not 6 into 7, it is 7 into 6. Likewise, it has to be equated. Any doubts or clarifications needed in this? Okay. Shall I erase and move on to the next question? Okay. Only one, man. Either we can equate by this or we can equate by that. That is all. Is it? Okay, whatever. Shall I erase this? Now look at the next question. More than one answer type. Oh, sixth question. Yes. (18p r minus 1) is 2. Is 2 means divided by 17p r minus 1 equals 9 by 7. Then we have to find r. Okay. 18p r minus 1 is equal to 9. No, it does not work like that. We will take cross multiplication. I will tell you how to do. See, 7 into 18p r minus 1 equals 9 into 17p r minus 1. Are you following? Then this can be written like 18 factorial divided by 18 minus r minus 1 factorial. Okay. So 9 into 17 factorial by 17 minus r minus 1 factorial. So 7 into this 18 factorial by 18 minus r plus 1 factorial equal to 9 into 17 factorial by 18 minus r factorial. See, minus r plus 1, 18 minus r. Same way, man. Okay, I'll write it that way. See, 17 minus r plus 1 whole factorial. Okay, this minus I substituted inside, distributed inside. Okay, then these two can be simplified. Only 18 is there, and these two can be simplified only 2. So we have 14 is equal to, not 14. See, 14 by here 18 plus 1, that is 19 minus r factorial, that is equal to 1 by 18 minus r factorial. Okay, now which one is bigger, 19 minus r or 18 minus r? No. Because if we expand this expansion, 14 by 19 minus r into 19 minus r minus 1 factorial equals 1 by 18 minus r factorial. What is this 19 minus r minus 1 factorial? It is (18 minus r factorial). There also these two will get cancelled. Then simply cross multiply. 14 is equal to 19 minus r. Then r is equal to 5. That's all. This 14 goes there, r comes here, 19 minus 14, it is 5. Any doubts or clarifications needed on this? Okay, then shall we move on to the next question? So look at the question number 9. That also can be easily solved. 9p5 means what? Yeah, you want me to solve, or can you able to solve that? You can able to solve. Okay, good. Next, question number 10. Find the number of ways of arranging the letters of the word triangle so that relative positions of the vowels and the consonants are not disturbed. We have the word triangle. This should be arranged in a way such that vowels has to change it in between them, and consonants has to be changed or shuffled in between them. How many vowels are there in this word? I is a vowel, A is a vowel, E is a vowel, A, E, I, O, U. Only 3 vowels. Okay. How many ways these 3 can be shuffled? No. See, these 3 things, which means we are arranging the word once again. How many letters? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. In this box, vowel should come. Okay. This box has how many chance? Totally how many vowels, man? Any one vowels can be filled here, right? 3. This one. So the vowels can be arranged in 3 factorial ways. Into consonants, 5 factorial. 1, 2, 3, 4, 5. That is all. So the relative positions of vowels and consonants are not disturbed. Okay. Okay. You said the same in the beginning itself. Okay. Then we'll go with your answer. Next, question number 11. Find the number of signals can be given by using any number of the flags. Underline that word, any number of the flags, from 4 flags of different color. We have been given 4 flags of different color. Using that, we can use any number of flags. Either we can use 1 flag or 2 flag or 3 flag or all the 4 flags at a time. That should make different signals. Okay. So as we discussed earlier, it has we can be used like we can use the flags like 1 flag at a time. 4 different flags given, we are using 1 flag at a time. So total number of ways it is 4p1 plus either we can use 2 flags. In that case, the total number of ways 4p2. We are adding all this just because the question has any number of flags. Okay. Next, 3 flags we can use 4p3, 4p4. That is all. Okay. Any clarification needed on this? Okay. Then we'll move on to the next question. Find the number of 4-letter words that can be formed using the letters of the word equation. We have been given the word equation. In that there are 3 subdivisions are there. First one, begin with a vowel. How many letter word we are making? Right. 4-letter word. Okay. First subdivision, begin with a vowel. So how many vowels are there? A, E, I, O, U. 4 vowels. 4 or 5? So first box has how many chances? 5 chances. Any one of the 5 can be filled. Okay. And then remaining how many boxes are there? 3. These 3 letters can be chosen from anything. Also remember that among these 5 vowels, only one we already chosen. So the total number of letters reduced to how much? 7. From that 7 we need 3. So it is 7p3. That's all. The second subdivision. The second subdivision states that begin and end with vowels. Begin and end with vowels. 1, 2, 3, 4. Then there are 5 vowels in total. We need 2. These 2 boxes can be filled in how many ways? No, 5p2 ways. Or else no. Begin and end with vowel. These 2 boxes can be filled in how many ways? 5p2. No, not both are same. Okay. 5p2 is equal to 5 into 4. This has 5 chance, that has 4 chance. Okay. That like how many times we will calculate? Simply 5p2. So 2 letters has been chosen. Then total number of letters reduced to 6. From that how many letters we want? 6p3. That's all. Or else as you said 5 into 4 into 6p3. Yes. Oh sorry, 6p2. I put it as 5 boxes. 2, 3, 4, 5. My bad. 6p2. Sorry for that. Okay. Then third subdivision. End with a consonant. 1, 2, 3. End with a consonant means how many consonants are there? 1, 2, 3 consonants only there. So this box can be filled in 3 ways. After choosing one consonant, the total number of letters will be reduced to 7. So 7p, 3 into 3, or else 7 into 6 into 5 into 3. Okay. Which one is easier for you? 7 into 6 into 5 or 7p3? Both are easy. Okay. Then question number 13. Mixture. Find the number of how many letter words? 4 letter words that can be formed using the letters of the word mixture. Wait, man. Totally 7p4, but they gave some constraints. Contain the letter X, which means any one box this X can be arranged. Okay. Any one box this X can be arranged. That X can be arranged in how many ways? Only one way. Okay. Oh. Yes. That can be any box. So 1, 2, 3, 4. 4 ways the X can be arranged. After arranging the X, remaining how many boxes will be there? 3 boxes. In that, except the X, remaining things 6p3. That's all. And next, the second subdivision does not contain X. You just remove this X. Totally, how many letters are there? Are you making 4 letter word? Yes. Then 6p4. That's all. You leave X remaining and all. From the remaining you can take anything. Only X should not be there. Okay. Simply 6p4. Clear? Next. Question number 14. Arranging the letters of the word organic so that all vowels come together. How many vowels are there? This thing we can consider as 1. Then the remaining R, G, N, C. So totally how many elements we are arranging? 1, 2, 3, 4, 5. 5 elements. So how many ways this can be arranged? 5 factorial ways this can be arranged. Not 5. We are not choosing something, man. Okay. Clear? We are not choosing something. We are arranging everything. How many ways this can be arranged? 5 factorial. In between this vowels itself, how many arrangements can be done? 3 factorial. See, 1, 2, 3, 4, 5 letters we chose. This considered as 1, right? Remember that bookshelf question. How many ways books can be allotted? That books can be shuffled in how many ways? The same way. So here we can arrange this in any other way. First box has 5 chance, this has 4 chance, 3, 2, 1. So in 5 factorial ways, all the 5 can be arranged. After arranging, any one box will be splitted like 3 for this vowels. In that, this vowel can be arranged in how many ways? This has 3 chance, this has 2 chance, this has 2 chance. Sorry, 1 chance. That is why 5 factorial into 3 factorial. Okay. Any clarifications needed in this? Okay, good. Then any subdivisions, another subdivisions, the same question. No vowels together. No two vowels come together. See, first subdivision is all vowels come together. We answered for that. Now we are moving forward to no two vowels come together. When no two vowels come together, that can be arranged in between consonants. Then only the vowels cannot be together. Now write the consonants alone. R dash G dash N dash C. Front also can be allotted, back also can be allotted. Okay. How many ways, if this arrangement has been done means no two vowels will come together. Okay. How many ways this R, G, N, C can be allotted? 4 factorial ways. Into, after arranging this 4, we have how many vowels? 3. The 3 vowels should be arranged in 1, 2, 3, 4, 5. That 5 places, how we can arrange 3 vowels? Which means for that 5 space, we are taking 3 from that. 5 space, taking 3. 5P, 5P3. Okay. You remember that EAMCET, that question, same way. Okay. Third subdivision. Three vowels can come, one vowel can come here, one vowel can come here. Together, not adjacent. No two vowels come together means what? Vowel should. No two vowels means any two among the 3 available. Any 2 if you take, that should not come together. That is the meaning. Okay. Next, third subdivision. Remember the triangle question previously solved. Relative questions not disturbed. How we answered for that? These vowels in between them. How many ways it can be arranged? Five factorial, sorry, 4 factorial. 1, 2, 3, 4. Why 2 factorial? 3 vowels can be arranged in 3 factorial ways. Remaining how many consonants together? See, what is the question? Relative questions of vowels and consonants not disturbed. Okay. So, organic means we are arranging the word like this box is for vowels, this box is for vowels, this box is for vowels. How many ways these vowels can be arranged? 3 factorial into this box is for consonant, this box is for consonant, this is for consonant, this is for consonant. How many ways this box can be filled? That is all. That is how this answer came. The triangle question also we done the same. Shall I erase everything? Integer type question. There are k distinct white and k distinct black balls, not ribbons. Not ribbons, that is balls. Erase and write balls. If the number of ways of arranging them in a row so that neighboring balls are different colors is 1152, then find the value of k. So totally how many balls are there? Question number 16. So k white balls, k black balls. How many way? Yes, man, white ball and black ball only I wrote. Yes, k white ball, k black ball. Read the question. There are k distinct white and k distinct black balls. If the number of ways of arranging them in a row so that neighboring balls are of different colors. So neighboring balls are of different colors means white, black, white, black. Likewise, we should arrange. So if we started with white means we will end up with black. Some other possible arrangement also are there. We can start with black, end with white. In this, how many ways these white balls can be arranged? Totally how many white balls? K white balls, so k factorial. Same way B also k, that is also in k factorial ways it can be arranged. Similarly, we have two different kind of arrangements, both are same. So 2 into k factorial into k factorial. That is equal to 1152. That will give you k factorial squared is equal to 1152 by 2. 1152 by 2 is what? Cancelled. We have 5 2s are 10, 7 times 5 7 6. So we have k factorial is equal to 24. Then k is equal to which factorial is 24? 4 factorial is 24. Okay. Any doubts on this? Shall I erase? K factorial into k factorial. See, white balls are k, can be arranged in k factorial ways. Black balls also k, that can be arranged in k factorial ways. So k factorial into k factorial it is clear. Likewise, two arrangements can be done. That is why I multiplied this two. Okay. Okay. Then look at the next questions. The number of ways of arranging 5 boys and 5 girls in a row. Okay. All the girls together, which means all the girls together should be considered as 1, and along with the 5 boys it is 6. So how many ways this 6 can be arranged is 6 factorial ways, and among the girls they can be arranged in 5 factorial ways. Just a minute. See, there are 5 boys and 5 girls. All the girls together considered as 1. Along with this 5 boys, it is 6. It looks like we are arranging 6 people, can be arranged in 6 factorial ways. And this 5 girls themselves can be arranged in 5 factorial ways. Just the previous thing we done, right? The same way. Also, the next one, no 2 girls are sit together, which means first boys can be arranged. Boys can be arranged in how many ways? 5 factorial ways, and in between them 1 2 3 4 5 6 gaps are there. In that 5 girls can be arranged, 6p5. Okay, not 6 factorial, man. In the 6 gaps we are selecting 5 and making them sit there. So 6p5. The 6p5 is 6 factorial only. Then boys and girls alternatively. Same. See, boys and girls alternatively. Either we can start with the girls, end with boys. Okay. So these arrangements can be done in 5 factorial into 5 factorial ways. Boys can be arranged in 5 factorial ways, girls can be arranged in 5 factorial ways. So like that we have 2 arrangements. So 2 times 5 factorial square, that is all. Okay. The remaining questions and all we will see tomorrow.